All right, folks, so this is part three from question 1A in the November 2025 HL paper 2 time zone 1 paper. As always, remember that you need to read the question very carefully when you start. You have approximately 90 seconds to mark, so that's going to be a roughly 3-minute question. 2 marks. So, explain why the first ionization energy decreases as you descend group 15 from nitrogen to bismuth. Okay, so there you have the first ionization energy, the fact that it decreases, and exactly where it should be. Well, if you don't recall, go back to your periodic table, you'll see this. Nitrogen is here, bismuth is here. All right, you've got 2 marks. So the first mark is going to be basically what is first ionization energy and what accounts for the decrease. And the second is going to be the explanation of the mechanism behind that. Okay? So I would start with what is first ionization energy. First ionization energy is in the removal of a valence electron. Now, if you recall, you're basically removing an electron. It's the outside shell. Here's nitrogen. Nitrogen has a positive 7 in the nucleus. It's got 7 electrons, 5 of which are in the valence shell. Okay? So what is happening as you go from down this group from nitrogen to bismuth? Well, what's happening is nitrogen only has 2 energy levels, whereas bismuth has 6. Okay? So you're removing a valence electron that is farther away. Farther from the nucleus. As you descend group 15. Now the thing is, some of what you say in a test answer may not actually be in the mark scheme, but you don't know what's in the mark scheme. And the way that the IB grades things, they look for things that are correct, not things that are incorrect. So if you happen to write something down that's not in the mark scheme, it's no big deal unless it's just chemically untrue in some way. So that's the first of the marks. Now, why is it that being further down is going to require less ionization energy to remove that, for example, than that one? Well, that's because you have more shielding from core electrons and less attractive force between the nucleus and the outside electrons. Now, just as a reminder about that whole shielding thing, both bismuth and nitrogen have 5 valence electrons. So that means that nitrogen, this nucleus is quite close to those valence electrons on the outside, whereas bismuth, it's quite far away. There's a lot of electrons between here and the nucleus, so therefore the attractive force is less. I don't know that you necessarily have to use the concept of shielding, but it is a concept that is in the syllabus, and this is a good time to use it. Okay, so let's have a look at what the mark scheme said. So the mark scheme said electron removed from a higher orbital shell energy level. Okay, we got that with the valence electron thing. further away from the nucleus. All right, great. So there's one mark right there. Now, why does the ionization energy go down? Because it's more shielded, or there is a lower attractive force between the nucleus and the outer electron. And yeah, that's pretty much exactly what we said. So the final part of this question is part 4. So please have a look at the part 4 video for that. The links to both the question papers and the answers are in the description of the video.